Welcome back. The objective of this video is to verify trig identities, but we'll have to find a common denominator, and we'll also learn how to use conjugates to achieve our goal. So in example 5, we're asked to verify using the Pythagorean identities. Our goal here is to first get a common denominator, because we don't have a common denominator here. And this one does look kind of sneaky. We could possibly do a conjugate here of 1 plus sine of x, but I don't know if that would be helpful. But sometimes with trig identities, it's try something, see if it works. If it doesn't, then you got to try something else. But we're going to start. We've got cosine of x over 1 minus sine of x over cosine x equals secant x. So we're going to manipulate the left side. We're going to leave the right-hand side alone, and we're going to get a common denominator in this one. So we multiply both sides by cosine x, or the cosine x over 1 minus sine x by cosine x over cosine x, and we multiply the sine x over cosine x by 1 minus sine x over 1 minus sine x, and that will give us a common denominator on the left-hand side. So I end up with cosine squared x minus sine x times 1 minus sine x. Be careful with this minus sign. It's fraught with peril. We'll see how that goes. And then our common denominator is just cosine x times 1 minus sine x. Now don't go canceling things here. You're going to end up canceling your common denominator that you just created. What we need to do is simplify our numerator and then see what we can get to cancel. So I distributed sine x here, and so I get cosine squared x minus sine x plus sine squared x all over our common denominator. Well, this cosine squared x plus sine squared x, that's our Pythagorean identity. These two guys combine to equal 1. You don't have to rewrite this, but I'm going to do it for purposes of the video. Cosine squared x plus sine squared x minus sine of x all over our common denominator. That equals our secant of x. Well, this is 1. So we end up with 1 minus sine x all over our common denominator of cosine x times 1 minus sine x. Notice in my denominator I didn't distribute that. I left that factored because look what happens. Now my numerator and my 1 minus sine x in my denominator cancel. And so I get 1 over cosine x equals secant x. Now I ran out of room working down the page, so 1 over cosine x does simplify, and we get secant x equals secant x, and I have now verified my trig identity. In example 6, now this one we are going to use the conjugate. So conjugates, remember, are differences of two squares. Okay, conjugates are like a plus b times a minus b, which gives us a squared minus b squared. Okay, that help get rid of square roots. So we really like conjugates, and they're going to help us in this problem. So we're going to leave the right side alone again, and we're going to simplify the left side, but we're going to multiply by the conjugate top and bottom. So I'm going to multiply by 1 minus sine of theta all over 1 minus sine of theta. So when I do that, I'm going to get cosine of theta minus sine theta cosine theta. Actually, I'm not going to distribute that after all. So just showing my work, I get 1 minus sine of theta times cosine theta all over 1 minus theta sine of theta times 1 plus sine of theta. So that denominator is going to become 1 minus sine squared theta. Well, this denominator of 1 minus sine squared theta is part of our Pythagorean identity. In our Pythagorean identity, and you're going to memorize this, right? We have sine squared theta plus cosine squared theta equals 1. Well, if we subtract sine squared theta from both sides, we get cosine squared theta equals 1 minus sine squared theta. So 1 minus sine squared theta can be written as cosine squared theta. Similarly, 1 minus cosine squared theta will equal sine squared theta. That's just rewriting the Pythagorean identity by subtracting either sine squared from both sides or cosine squared from both sides. So you will memorize that 1 minus sine squared theta does indeed equal cosine squared theta. So we end up with our numerator of 1 minus sine of theta times cosine of theta all over, I don't need that parentheses there, all over 1 minus sine squared theta now is cosine squared theta. So that is the only change between those two steps. And that equals the right-hand side. Well, now one of my cosines can cancel, and I get 1 minus sine of theta over cosine theta does indeed equal our right-hand side of 1 minus sine theta over cosine theta, and we have verified that identity. And that wraps up getting a common denominator and using a conjugate. Please, please, please commit to memory that 1 minus sine squared theta equals cosine squared theta, and 1 minus cosine squared theta equals sine squared theta. They will replace each other frequently in trig identities, and you'll get some more practice with this when I see you in class.